All right, Chapter 4, Mercury and the Moon. We'll find out today why these two objects, which aren't close to each other in space, one is a planet, one is a moon, we'll find out soon why they're in the same chapter. But first, let's look at a couple of the basic facts here. Obviously, the moon is our only moon, our only natural satellite. We have thousands of human-made satellites. Mercury has no moons, by the way, and it is the smallest planet now that Pluto has been demoted to dwarf planet. It is a terrestrial world, meaning it has land that you can walk on. And of course, it's the closest planet to the sun. Now let's look at these two objects side by side, and you can immediately see why they would be in the same chapter. They're incredibly similar. Most of you probably, at a glance, many people probably wouldn't know which is which. That's Mercury on the left and our moon on the right. Now, that's not to scale. Mercury is larger than that side by side, just showing how they look so similar, both grayish in color, and they both have lots and lots of craters and rocks and dust and things like that. And a lot of this has to do with the fact that neither one of them has an atmosphere. That's one reason they have a lot of dust and craters, because they have no protection from little micrometeoroids flying around in space. And it's why they have extreme temperature ranges, because they have an atmosphere is like a blanket of air. And when you have no blanket, there's no way for heat to transfer around a planet or a moon. And so check this out. Our moon, it's amazing. You could be in one location and it's hot enough to boil water, way hotter than that, and then step into a shadow and it's colder than any temperature that we've recorded here on Earth, at least in modern times. So pretty amazing. And you think about the spacesuits they had to wear back in the 60s and 70s walking on the moon, and this is one of the things that they had to deal with, this extreme temperature range, and yet it is not the greatest range. That distinction belongs to Mercury. Check that out. Pretty crazy. Now let's get this straight. Mercury is not the hottest planet. It is not the hottest planet in our solar system, but it does have the greatest temperature extreme. So that is its claim to fame. Over 1,000-degree difference. Here's Mercury from the Messenger spacecraft. And it looks a whole lot like the moon. Very, very rough surface, obviously. It's considered to be an old surface, an ancient surface, because there's no erosion. There's no water and wind to smooth it out there. All right. As I already mentioned, neither one of them has an atmosphere. So why don't they have an atmosphere? Number one reason, low gravity. Okay? Molecules of air escape, just like a rocket escapes from a planet. And the less gravity there is, the easier it is for those particles to escape. So basically, the smaller places tend not to have atmospheres. Places like moons and asteroids typically don't. But there are other factors involved, like which gases are you talking about? For example, I can think of a planet where the planet has enough gravity to hang on to heavier gases like oxygen and carbon dioxide, but it doesn't have enough gravity to hang on to lighter gases like hydrogen and helium. What planet am I thinking of? Well, that would be planet Earth. Venus, too, for that matter. But Earth, that's why helium balloons float. We don't have enough gravity to hang on to helium, but we can hang on to things like carbon dioxide. Now, another factor is the temperature of the planet or moon, which, of course, is often dependent on the distance from the sun. There's a great example of this. There are two moons of almost equal size and mass, Jupiter's moon Ganymede and Saturn's moon Titan, the two largest moons actually in the solar system. Ganymede has no atmosphere whatsoever. Titan has the thickest atmosphere of any moon, and one of the thickest atmospheres in the solar system. So what's the difference? Well, Titan, being at Saturn, is twice as far from the sun. So we know from the inverse square law, that's 1/4 the intensity of light that it receives. It's cold. And it's so cold that allows it to hang on to gases like nitrogen, whereas Ganymede cannot. So, if I had to pick a single difference, I would go with density. Density is the big difference. Let's look at a table here, and you see they're about the same size, and all of a sudden you look at the mass, and the moon is only 1/80th the mass of the Earth. So what's up with that? If you look at the density, 3,300, Mercury, in case you're wondering, is not crazy dense. I mean, it is very dense, but it's in the same ballpark as Earth and Venus. So it's the moon that's sort of the odd man out in the inner solar system, and we'll find out later in the chapter why that is. But that's an important clue as to its origin, that it originated differently than other things in the inner solar system. You can also look at the gravity there. Mercury is going to have a stronger surface gravity then, but both places have less gravity than the Earth. If you take a look on the moon, this is crazy. A 180-pound person would weigh 30 pounds on the moon. 30. That's as much as, like, let's say a 1-year-old. So you'd have the strength of an adult and weigh as much as a 1-year-old. That'd be pretty fun. And on Mercury, yeah, you weigh over twice as much as you do on the moon, but you still weigh considerably less than you do on Earth. Now, I want to point out one last thing on here. It talks about Mercury having a large iron core. So that's one of the reasons it is so dense. It has a very large core compared to the size of the planet. So that's one reason that it is so dense. Anyway, thanks for listening.